Logarithms. Logarithms are nothing but exponents. In college algebra, you should get a more detailed explanation, but we're basically going to look at the definition and what's on your calculator. The definition of logarithms is if you have y equals log base a of x. Let me write that down. The log is short for logarithm. A is actually called the base. And since logs are exponents, whatever the log equals, in this case the y, that's an exponent. That's the exponent on the base. And the next is just called the output for most books. So when you look at what it equals, a to the y equals x, a is the base, y is the exponent, equals the output, which is x. So once again, when I read log ax, that's log base a of x. A is a subscript, it's below. Log and x are on the same line. A is below. Now on your calculator, let's bring up a calculator. Most of them have an log and an ln key. Log is called the common log. It's log base 10. So if you don't see a number underneath, it's understood to be a 10. And if you look at your calculator, you'll see that 10 above it. It's like a hint on what it is. If you see an ln, that's not a 1n, it's an ln. That's a natural log. Now it's understood to be log or log base e. E is called the natural number, therefore it's called the natural log. And if you look at the e right there, above the ln, you'll see the e. And e is similar to the number pi. It exists in real life. The e actually can be found by investing $1, 100% interest, compound it, and if you start like with monthly and then daily and then so on and so on, increasing the compounding periods in a year, the number that you'll get closer and closer to is actually going to be this decimal. That's actually where it comes from. So it's similar to pi. So we're just going to answer a few questions. So let's use the definition to convert to log. So the first thing we want to do on this 6x equals 216, write the word log down. Then always begin with the base. The base of the exponent is 6, and so that's the base of the log. And then use the fact that logs are exponents. What's the exponent? It's x. Since the log is an exponent, that means the log equals the exponent, which is x. And then the 216 remains. That is not an exponent. These are all on the same line. The 6 is below. It's a subscript. You don't need that line in there, by the way. So let me erase it. Next one, start with the word log. And then the base is a, so the base of the log is a. Since the log equals exponents, and the exponent is b, that means the log equals b, and what you haven't used is c. Now if you really want to know a way to check yourself, watch this. If I write it out like this, if I start at the base, I actually go in a circle. A to the y equals x. That's how we got that. 6 to the x equals 216. A to the b equals c. So now let's do this last one. Start the word log. Base is e. The log equals the exponent, which is 2, and v is left over. Check it. E to the second equals v. The thing about this one is log base c is the same as ln. So I can take all of this right here and make it ln. So it becomes ln of v equals 2. Natural log of v equals 2. Now let's go the other direction. This time we're given the log. We want to go to exponential form. So to do that, get rid of the log. We're not going to have a log in the answer. So start with the base. The base is 4. And what do logs equal? They equal the exponent. Since that 2 equals the log, 2 is the exponent on the base, and then equals what's left over. Once again, this goes in a circle. 4 to the 2 equals x. Now on this one, you don't see a number or a base. If you don't see one, that's called the common log. And remember, common log has a base of 10. So if you want to, and I recommend this, write it in. So now start the base, which is 10. Log equals exponent of 3. And then what's left over is what the expression equals, x. Now ln is the same as log base e. So you may want to rewrite it first as log base e of x equals -3. Now to write it in exponential form, start with the base, which is e. It equals the exponent, or log equals the exponent, which is -3. So that's the exponent on the e, and then equals x gives us the final equation. Once again, circle. Circle, buddy! E to the -3 equals x. Since we do have certain features in our calculator, certain logs, we're going to use that to find the answer to some of these. Log of 7. I just hit the log, that's common log 7. And we get something, we're going to go around to 3 decimal places. 0.845. Log base 10 of 1,000, that's just 3. You'll learn how I got that in college algebra, but for now, log base 10 is the same as common log. 1,000, and then equals, or enter, and we get 3. Natural log of 8, I have a natural log key, so I hit that, and then the 8. And that's approximately 2.079. Natural log of e to the third, answer's 3. Yeah, you'll learn how I got that in college algebra, but for now, natural log, I need the e. There's an e there, and there's an e there. I want to use that one that has the exponent. Maybe I won't. I ain't like that one. Let's use this one. It had too many parentheses on the other one. So natural log of e to the third, I prefer to use that one because it's a lot easier to write, a lot cleaner too. And we get 3, like I said. And then we have log of -1. Error. What that means is it does not exist. No solution. Has no answer. The reason why is the base is 10. What exponent on 10 gives us the answer of a negative number? Well, if you start thinking about it, if I raise 10 to second, get 110, anything like that makes it bigger. If I use negatives, see that? I won't get a negative. In fact, if I were to even graph 10 to the x, because the x gives us all possible numbers, all possible integers anyway. If I look, those are not negatives, those are scientific notation. But none of them are negative numbers in front at the beginning. It's not possible. You can't take the log of a negative number. You'll learn more about that in college algebra. Now, last thing we want to look at is called the change of base. This is once again for your calculator. A is the base. Now, for this first part, I have base B. That's because it doesn't. We can use any number we want for the base when we convert it over to the change of base formula. But what you want to use is either common log or natural log because those are both on your calculator. Now, when you do the change of base formula, all you're doing is taking this log and you're going to separate into 2 different logs and divide them out. Log x, log a. The base goes on the bottom. Base goes on the bottom. Keep that in mind. Base on the bottom. So that's why we always have the log a on the bottom. So let's do a couple examples so you can see what we're talking about. Log base 2 of 3. That actually equals, and I can use log or ln. I'm going to use log for the first example over log. The base goes on the bottom, which means the 3 goes on top, which now means that I can take out my calculator and type this in. Now be very careful how you type it in. On the TI-83s especially, make sure you close that parentheses and then the divided by. We get approximately 1.585. And that makes sense if you understand what logs are. When you see this log, we're asking for the exponent on 2 that gives us 3. So 2 to what gives us 3? Well, 2 the first is 2, and 2 squared is 4, so we will expect the answer to be between 1 and 2. And you can always check that. 2 raised to the 1 4.585. It's almost 3. It's not going to be exact. That's why the approximations. Let's do the next one. Log base 4 of 9. Now change of base says we have log of 9 on top and log of 4 on the bottom because 4 is the base of the original problem. Before we even type it in, let's just think about it for a second. 4 to the first is 4. 4 squared is 16. So we're looking for the answer between 1 and 2. Let's see what we get. Log of 9, make sure you close it. Divided by log of 4. And we get 1.585 again. What do you know? And there are reasons for that. Let's just do one more, just so you know that we don't always get the same answer over and over again. Let's do log base 2 of 27. So let's think about it for a second. 2 to the 4th is 16, and 2 to the 5th is 32. So we're looking for the answer between 4 and 32. So log of 27 divided by the log of 2. That's about 4.755. And just one more, just so you won't think that there's something strange going on, like you're always going to get an answer bigger than 1. 2 log base 8 of 3. Log of 3 over log of 8. We get a number that's less than 1. Because 8 to what power is 3? Well, 8 to the first is 8, so it has to be less than 1. We can't get negatives. 8 to 0 is a 1. See, 8 to the 0, yeah, is a 1. It's not 3. 8 to the 1 is 8, so that's between 1 or 0 and 1. Let me say that again. 8 to the 0 is 1. And 8 to the first is 8. And we're trying to get an answer of 3. That means that our answer is between, since 3 is between 1 and 8, our answer is between 0 and 1. Let's see if that's the last one. I think it is. Change of base. Extremely handy.